Today we're going to talk about transformations. Okay. So in your packet, page 3, does anybody know what a transformation is? I think you will want to show you somehow. So a transformation changes the position or orientation of a figure. Okay? Now, we're going to look at a few different transformations. The first one on that page 3 says a translation. Okay? A translation means the figure slides. I want you to circle or box that word. The figure slides along a straight line without turning. Okay? If I'm going to translate myself, what do I do? Is this a translation? No. What would I do if I wanted to translate myself? Kayla. I have to slide. Did I translate myself? Yeah. Did I translate myself? Yeah. I slid along a surface without turning. I'm still facing the same direction. Right? There's another translation. There's another translation. There's a translation. Okay. Still facing the same direction, but I've been sliding. Is this a translation? Yeah. I just slid at a diagonal, right? It's okay. Okay, so a translation is when you slide. Here's how I remember it. There's an SL in translation. There's an SL in slide. Okay, so you know when you're translating something, you slide it. Okay? The next one is a reflection. Okay. The figure flips across a line of reflection, creating a mirror image. So if I do this, did I reflect myself? No, what do I have to do to reflect? Look at a mirror, right? Then you see your reflection. Okay? Or I'd have to flip myself. Right? Flipping is reflection. You are kind of a reflection in yourself. Do you know where the line of reflection is on yourself? Right here, right? If I drew a line right down the middle of me, is it a reflection? Kind of. Maybe not totally. Maybe I have a freckle on this side that I don't have on this side. But it's about the same. Okay? So circle flips. I would underline the FL. There's an FL in reflection, there's an FL in flip. Questions there? Okay, the last one is a rotation. Okay, and in a rotation, the figure turns around a fixed point. Okay, so if I'm going to rotate myself, I have to stay in this same spot and turn. Okay, I rotated around a spot on the floor. Okay, if I did a cartwheel, is that a rotation? Kind of. Where's my point of rotation, though? It's not on the floor. Probably like my belly button. Okay, I'm kind of rotating around that point, in a way. Okay? So in a rotation, the figure turns. And I typically remember turns starts with T, there's a T in rotation. Okay, then there's one more that's not on here. Okay, and I'm just going to have you add it. It's called a dilation. Okay, and I'm going to show you the dilation. Okay, so I want you to find somebody sitting near you and look at their eyes. I know it's kind of weird, right? Okay, I want you to stare at their eyes. We'll do this a couple times. You got to be looking close enough that you can see the pupils of their eyes. So if they have really dark eyes, it's a little bit harder to see. But, okay, ready? Watch their eyes. It's going to get really dark in here, and then I'll turn the lights back on. Watch their eyes. Ready?
Oh.
Did you see it? Okay, so if you didn't look at somebody, we'll do it again, because it's cool. Okay. Watch your eyes. Ready? Are you ready? And you actually physically saw it happen. Okay, that's a dilation. How many of you have ever gone to the eye doctor and had your eyes dilated? It's weird, right? Okay? If you go to the eye doctor and they dilate your eyes, they actually make your pupils bigger, and they stay like that for a little while. And then when you walk outside and it's really bright, you literally can't see. Because it's like your eyes are allowing too much light in. It kind of hurts. Okay, it's a weird feeling. But a dilation is to make it larger or smaller. It was maybe hard to see when I shut the lights off, but when I shut the lights off, everybody's pupils got bigger. And then when I turned them on, they all got smaller. Why do they get smaller when I turn the lights on? Yeah, so your eyes don't let in as much light. Okay? So sometimes when you wake up in the morning and it's really bright, it hurts your eyes. Right? Or like when you walk outside and the sun is shining really bright, you're like, oh. Because it takes a moment for your eyes to adjust. Okay? So a dilation is to make it bigger or smaller. Okay. So, the next one, we just want to identify the type of transformation it is. What's number one? What would we call that? Go ahead. It's a dilation. Because it's not the same size, it actually got bigger. So this is a dilation. How about number two? What's the second one? That's a translation. And I know some of us would like to say slide, but we want to use the correct terminology. How about number three? Really? Went from here down to here. Yeah, that's a translation. I didn't turn it, I didn't flip it, I just slid it down. So translation. And number four, a reflection. Okay, there's an imaginary line about right here. And if we flip it on top of there, it would land on top of each other.
Oh, could they be one and one?
Sometimes it can be, yeah. So I could reflect it and then turn it. Right, then it would be both. So that could happen. Today I'm only going to do one. We're just going to do one.
So for like number one, it could be trans.
Well, we could say, yeah, you're right. It kind of is slid and then blew up. But in order to show that it's larger, I kind of had to move it over. Okay. All right. How about this one? We'll call this one number one. What is that? Caleb. That is a reflection. Okay, let's go to this one, number two. What's that? Exactly. Translation. How about number three? What do you think that one is? Is he?
Reflection.
It's actually not a reflection. This one's kind of tricky. So if you look at this side right here is longer than this side right here. Right? So if it was reflected, they would have to land right on top of each other. So it's not a reflection. It's actually a rotation. Okay, it's rotated around this point. So this side ends up over here. Did everybody see that now? It's kind of rotated around. Okay, if we spin it. Okay, and the last one, number four. What would that one be, Brinley? Translation. Okay, questions there? That's kind of the easy part of this. Now, the next part of this, we need to understand some terminology. And this is where, on the MCA test, kind of what it's going to look like. They're going to give you a problem with this. Okay, and it says, the vertices of a triangle are A, B, and C. Draw the figure and its image after the translation, 1 unit left and 4 units down. Okay, so first of all, let's draw the figure. Okay, we have to remember how to plot a point. Do you remember how to do that? Okay, if I want to plot this point 1, 3, okay, the point 1, 3 means to go right 1 and up 3 from the origin, from the middle. Okay, so I'm going to start at the middle and I'm going to go right 1 and up 3 and put a dot there and label it A. Okay, then we have the point 4, 3. So what does that mean to do? Caleb.
4 right and 3 up.
Okay, so 4 to the right and up 3. This is point B. And then we have point C. The 3 tells me to move 3 to the right and 0 up or down. So 3 to the right and 0 up or down, there's C. And then I'm going to connect the dots. Here's a triangle. Okay, so we have this triangle. Now we're going to translate it. Translate means to do what? What are we going to do with it? Slide, right? Okay. So I'm going to slide this. And we're going to slide it 1 unit left and 4 units down. Okay, here's how we're going to do that. It's really easy. We're going to take each point. I'm going to take point A and I'm going to move it 1 unit left and 4 units down. 1, 2, 3, 4. And I'm going to put a dot right there. So 1 unit left and 4 units down. What should I label that point? I can't label it A because this is already A. Well, this is B. So I'm already saying D. But I want people to know that it's like the new A. So here's what's going to happen on the MCA test. This is what you're going to see. You're going to see it labeled A with a little dash on it. It's called A prime. That means it's the new point. Okay, so it's A prime is right there. Then we're going to take point B and we're going to move it 1 unit left and 4 units down. And we're going to label that B prime. Okay. And point C, 1 unit left, 4 units down. And we're going to label that C prime. And connect the dots. Is it the same exact triangle? Yeah. We've just slid it over and down. Okay, now we are going to list the new points. This is what you're going to have to do on your homework. What's A prime? What point is that? If you had to tell somebody the directions of that point. Starting here, you would say, don't move it all left or right, right? So it'd be 0, and then go where? -1. So A prime is 0, -1. Okay, B prime. What are the coordinates of B prime? If I was standing right here, how would I get to B prime? Is
3, -1.
3, -1. I go right 3, down 1. Negative means you move down. And then how about C prime? What would C prime be? Brittany.
2, -4.
2, -4. So this is the new triangle. Questions there? Okay, flip the page. Okay, the next one I need to give you a graph. Okay, the graphs are really nice, but we don't necessarily need a graph. Okay, it says the vertices of a triangle are A, B, and C. The triangle is translated 2 units to the right and 5 units up. Okay, so let's write down our vertices first. A is -2, -1. Put that on the table. B is 0, 2. And C is 3, 0. Okay? Now, I'm going to take this triangle. If I were to graph it, it would be on that grid, and I want to move it 2 units to the right and 5 units up. Okay, when you move right or left, that's your X number. That's this coordinate, this first coordinate changing. And if I'm going 2 units to the right, am I adding to that number or am I subtracting from it? You're adding, right? So if I have a point right here, and I move it this direction, it's getting bigger. Right? So I have to add to it. So I'm going to take the X value and I'm going to add 2 to it. Okay, so then I'm going to take the Y value and I'm moving it up. Is it getting bigger or smaller? If I move it up. Bigger, so I'm going to add 5 to that. Okay, so we need to get our new vertices. We need to figure out our A prime, our B prime, and our C prime. That's what we're trying to find. Okay, this middle column, I don't really need to fill it in, but I need to be able to figure it out. I need to take my X value and add 2 to it. What's -2 plus 2? -2 plus 2, Tyler? 0. So the first number there is 0. I need to do the same thing for B. I need to do 0 plus 2. What's 0 plus 2, everyone? 2. And then we're going to take the X from C. 3 plus 2 is 5. We've got the first coordinates. Does that make sense? Okay, then we're going to do the second ones. We have to take whatever Y is and add 5 to it. So -1 plus 5. It's -1 plus 5. Okay, 4. Then we have to do 2 plus 5. 2 plus 5 is 7. And finally, 0 plus 5. 0 plus 5 is 5. Okay, that means if I were to graph this, it should work that I take a point like 3, 0. 1, 2, 3, 0. That would be right there. And if I were to move it right 2 and up 5, right 2, 1, 2, and up 5, 1, 2, 3, 4, 5. It should end up at 5, 5. Okay? Yeah. Okay? Now, when we get to the MCA test, and if they give you a problem like this, is it okay to graph it? Sure. Could you draw your own graph? Sure. Guess what? I'll even give you grid paper. Would that help? Right? I can't give you like lines on the, I can just give you grid paper. I can't give you like the X and Y axis, but you can draw that in yourself. Okay? All right. What if I asked you to describe the translation? Describe the translation of the airplane from point A to point B. The airplane is starting here at point A and ending here at point B. Describe it. What happened? Okay, it got lower, right? We want to always list left to right first. So tell me, how far did it move right or left, and how far did it move up or down? What would you say? It had to move 1, 2, 3, 4, 5, 6 to the right. So right, 6, and from there it went down 1, 2, 3, 4. Would everybody agree with that? The plane went right 6 and down 4. Questions there. Now, if I were to put that in this form, X and Y, if I said the plane started at X and Y, it ended at X plus what? 6. That would be the same as going right 6. How would I show down 4? -4 or -4. So this would describe the translation in math terms. So here we wrote it out, right 6 and down 4. Here we said, you just do your X coordinate plus 6, your Y coordinate -4. Means the same thing. Okay? All right, the last piece of this is rotation, or reflections. So here we have the vertices of a triangle, A, B, and C again. It says, draw the triangle and its reflection in the y-axis. What are the coordinates of the new image? Okay, first of all, we have to understand the difference between the x and the y-axis. When I look at this grid, which one's the x-axis and which one's the y? Can you remember? Label this if you need to. This is y, this is x. Okay. We are going to graph this. So let's start with our coordinates. We have A is at 1, -2. So starting in the middle, we're going to go right 1, down 2. And I'm going to label that A. So I'm right 1, down 2. B is at 4, -1. So I'm going to go from the origin, right 4, down 1. There's B. And C is at 2, 4. Right 2, up 4. There's C. Here's my triangle. Now it says reflected in the y-axis. Which way do I want to flip it? I'm reflecting it in the y-axis. Where am I going to flip it? Should I flip it this way, or should I flip it this way? Many of you were doing this, right? We're going to flip it across the y-axis. So we're going to flip it this way. So you have to imagine if we were to fold this, if I could take this TV and fold it along this line, where would point A end up on the other side? It's got to be the same distance away, right? Right here, it's 1 unit away. So it has to be 1 unit away on the other side. That would be A prime. Okay, how many units is B away from the axis? 1, 2, 3, 4. So it has to be 4 away on the other side. 1, 2, 3, 4. There's B prime. And C is just 2 away, so 2 away. Here is my new triangle. Is it reflected? Yeah, I could flip it on top of it. Let's list the coordinates. A prime is what? What's A prime, Savannah? -1, -2. It went left 1, down 2. B prime is -4, -1. And C prime is -2, 4. Questions there? Okay, let's try another one. Find the coordinates after reflecting in the y-axis. So let's plot our points first. We have -2, 4. Left 2, up 4. Label it A. On the same page. Okay, B, we have to go -4, 2. So -4, left 4, up 2. There's B. And C is -1, -1. There's C. Okay, if we're reflecting in the y-axis, we're flipping the same way again. This time we're just going to the other side. So there's 1 unit away, 1 unit away. There is C prime. B prime, it was 4 units away. So 4 units away, there's B prime. And A was just 2 units away. Here's my new triangle. Okay, let's list the coordinates. What's A prime? This time I kind of started on the phone. What's A prime? 2, 4. What's B prime? 4, 2. And then C prime would be 1, -1. Questions there? Okay, we're going to skip the next one. The only difference on the next one is that it says reflect in the x-axis. What does that mean? Instead of flipping left to right, what are you doing? Flipping up and down. But same process. Okay? And let's go to this last one. You plan to hit the golf ball along the red path so that its image will be a reflection in the y-axis. Does the golf ball land in the hole? Would it? No, right? If it's a reflection, right now the golf ball is 2 away. It needs to be 2 away. The golf ball would land right there. Does it land in the hole? No. No, it doesn't. That was a hard one, right? Difficult. All right. So then